Hello, hi. My name is Michael Hoffman. I'm a professor of philosophy at the Center for Ethics and Technology and in the School of Public Policy at Georgia Tech. This video walks you through a project on the Reflect platform. Reflect has been designed to help teams to deal with problems which are ill-structured. When it comes to problems, the question is how to approach them, and there can be three different ways that we can distinguish. The first one is to explore the problem. The second one is what I call seeking the truth, and the third one would be by means of deliberation. When it comes to exploration, what I mean is the question which issues are problematic, who is gaining from a certain decision, who is losing, what might happen in the future. All this is exploratory. Finding out the truth means what is the correct solution of the problem might be a paradigmatic question, or is it ethical to do X? How should something be regulated? All these questions assume a kind of God's eyes perspective where you think you find the correct solution. However, if we think about limitations, cognitive limitations that we're all facing, then the problem of framing becomes relevant. This one torch can represent a certain perspective when somebody is looking at the world and is seeing the world in a kind of frame. But other people would look at the same reality and see something completely different. And if we overlay these both framing processes, then we can see that one person perceives some part of reality and the other one another part of reality. And where there's an overlap, the perception or interpretation of what's common might differ significantly. So in this situation, it might be more interesting to think about what I call collaborative reframing. That means talking and deliberating and finding out what the best way to frame reality might be. When it comes to deliberation, the idea is we should talk to those who are affected by the problem. So the question is, who has a stake in it? And then what would these stakeholders propose should be done to solve the problem? How would these stakeholders describe what exactly the problem is? So the main goal of a project on the Reflect platform would be to develop a proposal that can satisfy the interests, needs, and values of all stakeholders. We call this a symphysis proposal. The Greek word symphysein means growing together. So in contrast of putting something together, like in the concept of synthesis, symphysis focuses on the evolution of a proposal in deliberation. That means it becomes better and better over time. The process in which you will engage as a team is called reflective consensus building. It is inclusive, deliberative, and reflective. Inclusive means that the first task will be to identify all the stakeholders that are relevant for a particular problem, and then to consider their positions and perspectives, or to engage them directly. Deliberative means you have to ask yourself, how exactly should the problem be formulated? What would the stakeholders propose should be done? Why would the stakeholders propose what they propose? And what are the interests and values that motivate the stakeholders? Reflective means that in the process you have to go back and revise time and again. You have to revisit the problem formulation, the stakeholder analysis, and you will see that the stakeholder determination depends to a large degree on the problem formulation and vice versa. You have to think about the symphysis proposal and go back and revise it, and you have to think about justifications of your symphysis proposal. Okay, now it's time to walk you through an example of a project that has been performed on the Reflect platform. This is about a team that worked on brain-computer interfaces. What I will do here is I will first talk about the problem formulation, Then I will show you a few slides about stakeholder analysis, and finally we will talk about the symphysis proposal. Now, with regard to the problem, I will start with showing you the formulation that was initially provided by the instructor. Then I will show you the first attempts of the teams to formulate the problem, and then you will see the final problem formulation. With regard to the original problem formulation, it reads in the beginning, advances in brain-related science and technology open up new possibilities of bridging the boundary between what is inside and outside of our head in both directions. What this means with regard to both directions is that on the one hand, we can analyze brain activity and use the analysis, for example, to use external devices like robotic arms or something like that, or we move in the other direction by trying to either influence the brain, for example, when it comes to Parkinson's disease or other things. So that's meant by both directions, and the problem formulation is much longer, but that's not the point here. More interesting is what you see here, namely the first attempts of the team to formulate something about the problem. The first thing that you will notice is that there's a clear distinction between more specific problem formulations and more general problem formulations. What that means is that when it comes to any technology or any problem, you can either focus on a more detailed view. So you pick, for example, a certain brain-computer interface technology instead of talking about all of them. Or to formulate the problem from a more general point of view would mean that you think about disease or whatever the problem is in a broader context, and not only focusing on certain technologies. Now let's have a look at these examples. First on the left on top, what the team proposed. Specifically related to thought interpretation, how would we trust this data is safe and will not be used for advertising and exploitation, such as related data from social media sites? What you can see here is, first of all, an interesting problem, but it is still very exploratory. It's kind of trying to figure out what is really relevant when it comes to brain-computer interfaces. Now let's have a look at the one on top on the right side. What is considered ethical in the context of this problem? What would make something unethical? Now this question is clearly driven by a truth-seeking attitude, as I mentioned earlier. So the question is formulated in a way that the goal would be to define, as it says, what is ethical and what is not ethical. That does not take into account a stakeholder analysis, for example. Now let's have a look at the one on the bottom on the right side. If you are tasked with designing the guidelines for a brain interface piece of technology, how would you expand that to include all technology that interacts with humans on a day-to-day basis? Now, in this formulation, it is clear that focusing on all technology that interacts with humans is indeed a much broader formulation of the problem. However, since the starting point is brain-computer interfaces and the question how to expand them, it seems to be clear that you have to work first on the problematic of brain-computer interfaces before you can ask the question how to expand this area. Okay. Let's have a look at the final problem formulation that the team submitted at the end. So that's kind of long, but I think I should read it so that you get really an understanding of what the team decided to do. They write, brain-computer interface technology is currently mostly used to help people with physical disabilities and sensual impairments, but scientists and doctors hope to use them in more advanced ways through cognitive and physical improvement, such as teaching people through a file upload and bionics. Cognitive BCI technology is still in its infancy, but there are already BCI applications that can detect private information about a subject, such as bank information and month of birth, by presenting a subject with relevant visual stimuli and then analyzing the EEG signals. So that's obviously an interesting description and interesting problem if you think that you show people something and then you are able to analyze the neural activity and figure out the bank information, things like that. But so far, the beginning of the problem formulation is really describing the context and the general problem. It goes into more detail and becomes more specific in the next part of the problem formulation. I continue. This project focuses on the development of cognitive improvement BCI technology designed for medical purposes. So that is a clear focus on a more narrow area, BCI technology for medical purposes. These technologies range from current devices such as cochlear implants, so the hearing aids, and devices that measure brain activity in Alzheimer's patients to see how their disease is progressing, to devices that may be developed in the future, such as a device that would allow patients of neurodegenerative diseases to communicate through a brain-computer interface. So communication as a future possibility of applying the technology. The problems that arise, and now you see it moves from the determination of the area on which the team is working to a concrete problem that has to be observed with regard to that. So I continue. The problems that arise from this focus is the possible collection of data and breach of privacy with cognitive BCI technologies, as well as the determination of whether or not cognitive improvement BCIs should be a right to have for those with medical conditions that can be treated with BCIs. So you see there are really two problems. The first one is collection of data, breach of privacy, and the second one is then whether people should have a right that the society as a whole is paying for this technology. So these are two different problems. And now the last part is determining the setting in which the team perceives itself. They continue. We are a team that includes hospital representatives, research company representatives, patients, government officials, and other stakeholders with the goal of recommending policies to the government to regulate and explicitly dictate data privacy laws such that all parties can securely and ethically conduct business. So that's saying, okay, we are a committee of these people with a clear goal. Also, and that focuses on the second part of the problem, these regulations must address the question of if and how much government assistance should or must be provided for individuals to acquire these technologies. With cognitive BCI technology on the rise, the importance of establishing ethical regulations increases every day. So that underlines in this last sentence the significance of the problem. Now, as you can see on the right side, the stakeholders that the team decided are relevant for this particular problem formulation are medical technology companies, citizens or patients, politicians, and insurance companies. It is kind of questionable whether politicians should be counted as stakeholders because either they are representing other stakeholders so that they do not really have a stake in it, and if they have really a stake in it, then the stake will probably be determined by the party to which they belong. So having stakeholders in general as stakeholders seems to be problematic. Okay, so this was the problem formulation, and after the problem formulation, let me show you their work on the stakeholder analysis. First, when you start working on the stakeholder analysis, you will see a screen that looks like this one. You see on top there's a distinction between stakeholders, proposals, reasons, and interests, and then the question marks provide information about what each of these terms means and what you have to do. So the first one talks about creating stakeholders. So you would click on this box and you would enter the first stakeholder that you identify as relevant for the problem. This takes a while right now. So, and if you move over this button, you see a menu which offers certain options, and we are clicking on add a proposal. So something that this stakeholder would propose should be done to solve the problem. Okay, so it pops up again, and then you would continue with reasons and so on. Again, if you mouse over, you see what the options that you can choose here to enter some things. Okay, now let me show you what this particular team did in their stakeholder analysis. So you see medical technology companies on the left as the first stakeholder. what you can see here, distinguish two proposals. The first one on top, we should allow the development of BCI, so that's what the stakeholder technology companies suggest. The reasons for that is we can profit off the sales of our technology. The interests that drive this reasoning are financial, as you see on top. Another reason for pursuing the development of BCI is we can provide a source of treatment, pain, to our customers, and the interest that drives this reason, they call it contractual. Now, moving down, this is another proposal. We should retain some level of control and so on. But now let's have a look at the patients and the citizens, what they would propose. So the citizens or patients would propose, we want our privacy to be respected when using BCI technology. Two reasons. We do not want to lose autonomy and independence over our own life in exchange, and so on. And you see the reasons, and then it's moving down. It's kind of fast here. Politicians, that's the third stakeholder. And finally, the proposals of the insurance companies. Okay, so after talking about the problem formulation and the stakeholder analysis, let me show you what this team finally proposed as their symphysis proposal. This is here distinguished in two parts. And you see on the left is a list of components. So the idea is you cut your proposal into different components. You might be able to then provide references so that the literature is integrated into this. And if your work plan includes justifications, then there would be links for justifications. Author refers to the student who is working on this component, and the order of the components allows you to rearrange the ordering at the end if you think things should be presented differently. Let's just have a look at the first three components. They write, all BCI technology companies should be restricted by law to collecting only the data that is necessary to the function of the device. No unrelated personal information may be recorded by a BCI device. So you see that refers to the problem of data security. Then second, any personal information required must be provided by the patient with their consent. And third, in the event the technology is capable of collecting more information than is absolutely necessary, then the user must be made aware of this risk and allowed to opt out of using this specific piece of BCI technology. So this reacts to a rebuttal that even though you might think that companies are restricted by the first component to collect only the data that are necessary, it is clear that any technology is able to collect more data than are absolutely necessary. And this third component tries to address that. So I only would like to show you how many proposal components this team distinguished in order to solve the problem. After walking you through this example of a team that worked on brain-computer interfaces, let me conclude with two more general considerations, one about user guidance and the last one on reflection. The main feature of the Reflect platform is that it provides guidance that allows you as a team to cope with a wicked problem like the one that we discussed earlier. User guidance is provided in the form of work plans and instructions that organize not only the activities of individuals, but the activities of teams and of entire classes. This kind of guidance, the main function is to reduce confusion in the face of wicked problems. And at the same time, it is important that the particular guidance that is provided by the work plans allows you to practice certain strategies to cope with these problems. So the strategies of coping with wicked problems are integrated or embedded in the work plans of the Reflect platform. Now, in order to show you what you will see first when you enter the Reflect platform, let me tell you something about your team page. The main thing that you see here is a distinction between the work plan on the left side and then more systematic navigation on the right side. So the work plan provides chronological navigation. That means you start from the top and work down, whereas the right side provides all the individual components of a Reflect project, like the problem formulation, the stakeholder analysis, and the proposal development. So what you see on the right side will be important to move forward and backward. But now let's start with the work plan. So the first thing says, do research on the wicked problem. It's an individual activity, and it refers to looking for literature, doing research, and using the knowledge base for that. If you read that, you would go to the knowledge base, and then you see on the bottom popping up a link to a knowledge base, which is outside of the platform, and instructions how you get there. Now, the next point would be the individual stakeholder analysis. Again, it provides instructions with the link to the page that you saw already. That's the one where you create your first stakeholders. The same page can then also be approached by using the systematic navigation, and you see how you get to the same page. Now, continuing here, the last step for the first individual preparation is working on the problem formulation. So you would do that individually, and then in the next meeting, that's further down, you do it in your team. Okay, here's a final word on reflection, because that is what the platform intends to stimulate. Besides giving thanks to those who are listed on this last slide, let me also say that I thank very much the students who agreed that I can use their material on the brain-computer interface. Thank you very much.